Okay. So before you go, make sure some people yesterday lab picked one up, but before you go, make sure you get one of these. Okay, so study guide for test one. Sig figs, be able to convert between, I give you a number, you should be able to determine significant figures. Including all the oddball ones, trailing zeros with a decimal point and no decimal point, et cetera. Conversions, metric conversions. 2 kilometers equals how many micrometers, something like that. Multi-step problem. We have multi-step problems on there, and that's including the 3 kinds. Remember yesterday we went over the 3 kinds of problems. There's a single unit to a single unit, a fraction to a fraction, and then there's multi-dimensional problems like linear, squared, and cubic. Those are the 3 types. So those 3 types will all be represented on this test. Now I'm going to be going over problems today, lots of problems, and then tomorrow as well. Now your dry labs are really good practice material for the tests. If you can do the dry labs okay, you should do fine on the tests. Okay? The test will be in here. It'll be on paper. If any of you have combinations, you can either go out in the hallway here, or you can go to the testing center. If you go to the testing center, you have to get a proctoring slip from me. And I'm going to give you the test in a sealed envelope, and you're going to go over there to take it. Okay. All right. And then tomorrow I'm going to show you a practice test. And I have many practice tests over the years. And basically, this is my philosophy on practice tests. I've mentioned this yesterday, some professors collect their tests afterwards. They'll pass out the graded tests and collect them. And they use the same test year after year after year. Boring, boring, boring. What I do is I have a different test each semester. And I like to give last semester's tests as a practice test. And it works out really well. I've been doing that for decades. And I think it's a better system for my students. So, okay, so any questions about the test? Okay, it'll be an hour and a half. I'm not sure you'll need an hour and a half, but it'll be an hour and a half in here. And then we'll, unless you have combinations, then we'll deal with those individually. Then we'll just go to lab. Okay? All right. Okay, so these are the problems we did yesterday. The first multi-step problem we had is going from miles to inches. Starting with 12 inches and then converting to miles. And it's not a 1-step problem, it's a 2-step problem, and you will need conversion factors. Now remember, whenever you're reading the text of the word problem and you see the word per, automatically think conversion factor. Per means a fraction. And then you always have the inverse of that fraction as well. Okay, so just start doing a bunch of problems now. Okay, how many centimeters are in 1.23 kilometers? Okay, so what's given? And we're trying to calculate centimeters. Okay, so that's given, calculate, and then we need to do the conversions going from kilometers to centimeters. Now, as we're looking at the table here, here's kilo and here's centi. Now, how many cents are in a dollar? 100. That's the easy way to remember centi. Cents, dollar. Kilo is becoming more and more common, especially in the recreational activities of people. Kilo seems to come up a lot. Milli comes up a lot regarding um, drug doses, etc., and micro as well. Depends on what drug you're taking. Mega used to be a big deal with hard drives back when computers first started back in the early 80s. Megabytes was a big deal. In fact, it was a big deal if you had a 5 megabyte hard drive. 5 megabyte hard drive. We had I taught at River City High School then, and I taught computer science, and it was a big deal. We got in a megabyte hard drive. We could actually, when we were running Pascal doing the compiling stage, we could actually move it over to the hard drive and it would go faster. It was like, and then along came gigabytes, 1,000 megabytes per gigabyte. Now we're talking about terabytes. It's like this computer has 2 terabyte internal memory, and my external has 2 terabytes, and I have another backup at home, 2 terabytes. So terabytes are pretty common nowadays, and it goes up from there. Some of these crazy images from NASA have like petabytes. These images are huge from the current technology and web telescopes. Really, really cool stuff. Okay, so we need a kilometer and a centimeter in our unit conversion. Now, the base unit, I like to teach base units in the metric system. For mass, that's gram. For length, meter. Volume, liter. So I always say, if you don't have a single conversion factor going directly from one to the other, convert to the base unit. And from the base unit, go to the other one. So in our case, we have centimeters and kilometers. So we're starting with kilometers. So we're going to go from kilometers to the base unit, which is going to be meters. Then from meters to centimeters. So it's going to be 2 steps. Now, when you're looking at this conversion chart, there are 2 ways to go on the conversion. There's this one and this one, and they're equal. Now, this is a problem with students when they're doing metric conversions, is that they need to understand what is bigger and what is smaller. And so the conversion is going to be a fraction. So if we look at conversion to go from kilometers to meters. Now, kilometers has to be in the bottom. Why does kilometers need to be in the bottom? Cancel. Given needs to cancel. Okay, so we can look at this a couple different ways. How many meters are in a kilometer? 1,000. Or how many kilometers are in a meter? and then a -3. A thousandth of a kilometer is in a meter. Both these are valid conversion factors because these are equal. And you'll find these on the data chart here on the bottom right. And some people like the negative exponents. Most people don't. So stick with the bigger numbers rather than resorting to negative exponents if that's uncomfortable for you. Now, either way, it'll work. Now, a good way to figure out whether your conversion factor makes sense or not, which is bigger, kilometer or meter? Kilometer. That means the unit in front of the kilometer needs to be smaller with the bigger one, bigger with the smaller one. So we have a bigger number here, the smaller unit. Small number here, big unit. You have to have a small and a big each time. Frequently, students will have big, big or small, small. That's the biggest mistake in this metric conversion. Okay, so does that make sense? Okay, so let's do this with both of these. Okay, so the first step is we convert to the base unit, which is meters. Next step is we go from meters to the centimeters. So the meters have got to cancel. And we have 100 centimeters in 1 meter. Centimeters small, hence the bigger number 100. Go with it. Meters big, so it's got the small number. And meters cancel, leaves us with centimeters. Okay, so that's the process when you're doing metric conversions. Usually it's two-step. First step, go to the base unit, whatever it is. Then from base unit to what you're trying to calculate. Now, some of you have had this before, and you can go, oh, well, there's 10 to the 5th centimeters in a kilometer. You do it in one step, okay? The problem with that, if you make a mistake doing it in one step, you won't get much partial credit. If you do base unit in 2 steps, even though it's 1 step longer, the chances are you will be able to do these smoothly, okay? Now, some of you are whiz kids coming from various places. Summer school is interesting. Last time I taught 1A, I had 6 students from Sierra in the class. Everyone else was from some other place. University of North Dakota, San Diego State, Sac State, Davis. No. Could have been one of my students. And by the way, the Chem A students, the only ones that got A's in the class.
Well, actually, he never was lived up here. He was born in Merced. He moved to San Diego. Unless he did teaching in Merced. At like Merced High School.
Okay, all right, so this is the setup, and again, 90% of the credit is for setup. So we've got so we're looking at 3 sig figs. How many sig figs are in conversion factors? Infinite. So our answer is going to be 3 sig figs. Okay, and my calculator gives me 1.23 times 10 to the 5th centimeters. Now, if you think about 1,000 is 10 cubed and 100 is 10 squared, when you're multiplying numbers with bases and exponents, you add the exponents. So 3 plus 2 is 5. Well, that's 10 to the 5th then. So 1.23 times 10 to the 5th. And lo and behold, that's what my calculator said too. Good calculator. Okay, okay, any questions about that?
It's about the one, so. We only know that 12 inches is 1 feet, can we just like write 12 inches goes 1 feet without writing the steps in the test, or we have to do a step for that too?
This is what I want to see on the tests. Setup, answer. 90%, 10% points wise. On the test, people were asking yesterday, should we put this number down and then convert it to that? That's fine. You don't have to, you just put the answer down. I like for you to put the big answer down just in case you made a mistake converting, because I can give you more partial credit that way. It's always, how can I give you more credit? That's what I'm telling you, all this extra stuff, optional. If you don't want the extra consideration, don't put it down. Okay, all right. Any questions about this guy? Yeah,
The conversion for centimeters to meters isn't given on this. So
Yeah.
how did you find the conversion?
yeah, it's if you go to centi, which is the fourth one up from the bottom, and go all the way over. See the two conversions going from the centimeter to the base unit meter. In this case, I use grams as an example.
Oh, that would also be.
Any base unit is interchangeable. So grams, meters, liters.
Would you dock us if we used the conversions at the top and we went from kilometers to meters to feet to inches to cent?
No,
I know it's like a longer process, but if they're already given, would it be?
yeah, you can do that. I mean, it would be, you still get the same answer though. Particularly if it's bold-faced conversion up above, those are exact. If it's not bold-faced, then it's an approximation. So it's not infinite if it's not bold-faced. Does that make sense?
Yeah.
All right, so any more questions about this guy? All right. Now remember I said, if the given is a fraction, what you're trying to calculate has to be a fraction then. You go fraction to fraction, meter to meter, square whatever to square whatever, cubic to cubic. Okay, so you calculate it and what you're starting with have to be the same. Okay, so what is the given in this problem? 34.4 miles per. Remember what I said you had per automatic fraction? That means you're starting with a fraction. So 34 miles per hour. And you're trying to calculate, now you have to calculate it basically into another fraction. Now, fractional problems are two problems built in together. The numerator and the denominator are separate problems. So your idea is we need to get hours to seconds and we need to get miles to kilometers. Separate conversions. Okay? All right, and it doesn't matter which you do first. Which one you want to do first? Huh? Miles to kilometers, okay?
Oh, I'm sorry. You meant, the hour of the clock.
Yeah, those are the two problems, sub-problems you have to work. You have to work them separately. It doesn't matter which one you do first. So did you have a,
Yeah, I said hours of the clock.
okay, we can't do hours to kilometers because hours is a unit of time and kilometers is a unit of length.
Okay.
Time to time, length to length. So you're on the spot. Which one do you want to do? Okay, let's do miles to kilometers. Okay. All right, remember the first thing we have to do is cancel the given. Okay, now we're doing the miles to kilometers. We have to cancel the miles. So miles on the first conversion has to be on the bottom. Otherwise, it won't cancel. Okay, and now we need kilometers per mile. Is there a kilometers per mile? There is 1,609. Now notice the 1 mile equals 1.609 kilometer is not boldface. That means it has 4 sig figs, not infinite. Okay, so now we are in kilometers. We're all done with that one. Now we've got to go down and do hours to seconds. Now hours have to cancel. So is it going to be in the top or the bottom? Top. So it cancels. It's on the bottom, it won't cancel. So let's go hours to minutes. And then minutes to seconds. Okay, does that make sense in terms of the two problems? So fraction problems are really two problems. Do the top one first or second, and bottom one first or second. And the reason why it doesn't matter the order is because we're doing multiplication. Multiplication, we can do in any order. It's commutative. Back in the old algebra days, right? Okay. So that's the setup. Let's get an answer now. Let's see here. So we have 3 sig figs, 4 sig figs, infinite, infinite. So what's our answer going to be? 3 sig figs. Okay, so that's what my calculator gives me. It gives me more, and I'm just going to write those down. Okay, so we go to the fourth place. It's a 7. That kicks the 3 up to a 4. So it's 154 I'm 10 to the minus 2 kilometers per second. That is a 3-step problem. Again, it's a game you're playing. Start with a given, and you're going to put conversion factors in until you finally end up with what you want to calculate. Like in Erin's situation, we did it in 2 steps, she did it in 3, same answer. Just throw it in conversion factors. Everything kind of keep canceling. It's just a game. Now you're going to see in lab 2 is a big hodgepodge of different types of problems. You're going to have some fraction problems, you're going to have some cubic problems, some square problems, some linear problems, a whole bunch of varieties. And remember, when you're reading the text, if you see the word per, you automatically have an additional conversion factor. And you've got it in 2 parts, the inverse of each other. Okay? And we're starting to see a pattern here now. Same thing. Given, calculate, setup. Setup is a bunch of fractions with everything canceling. Every single problem like that. Doesn't matter how complicated it is. Now, when you see your take-home problem tonight, you're going to have a page. Let's see. Okay, this is a problem I gave last fall. Let me say this, you only use the data supplied. Okay, you're going to be looking at the assessment of your country's carbon dioxide production for year 2011 from automobiles. USA only, not the total world. Okay, and these are the assumptions. Now you need to go through here and go, I don't care about the Sahara Desert. I just cross that off. Do I care about food being broken down from glucose, undergo combustion? No. Average temperature? No. Each person consumes a caloric intake of 2,000 calories per day. So now I use the same sheet for every take-home problem. So sometimes I'll say, each person in the world consumed 5 grams of glucose per day, per year, non-leap year. How many calories were burned? Then you're going to need how many calories does the average person burn per day, you know, blah, 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 blah. Okay, but again, you're going through and crossing off what matters. Does gasoline matter? Now, see, that could matter. So let's not take that off. It depends. Okay, coal. Coal's not being used. Density of coal. World population, we're talking about US population. All this other stuff is referring to cars. The problem is about cars, so we want to keep those. Now, all these are conversion factors. These are all fractions now I'm going to be using. So what's given here? What's given? That's what we're trying to calculate. Okay, so that answers the third question. Okay, so times the CO2 in USA in 1 year. Right? Okay. What's producing the carbon dioxide? Cars. So let's find out how many cars. Huh?
One car per family and
How many families we have?
uh families. They don't see that on paper right now.
Right here.
Per family, that's people per family.
Well, we know how many people there are, right?
Yeah, but there's one per car for that 3.16 people.
All right, so we found out how many 3.16s are in the total world or the whole US population.
Week.
So see the connections you're making?
Oh,
And this-
US, year 2011, families, automobiles. Those are your four really things you gotta think about.
Yep, you're on the right track.
Well, and then that, then equals, then you jump to the other hand, and that would be CO2. The info, the conclusion.
But the only information you know is how many grams of carbon dioxide comes per gram of CO2.
But conversion.
Okay, so you know gallons, what the gas mileage is, all that stuff. And the reason why I'm giving you 5 days to do this problem, it's a lot of conversions. And this is the most conversion you're going to have, but this is real. This is real data. 2011. That's how long I've been doing this problem. Since 2011. But it's real data. This is not BSy stuff from a textbook. And this is what people like at the county level and federal level deal with. They deal with problems like this all the time. Now they write programs where prompt you for this information, but the computer programmer that wrote the program did this problem as you're going to be doing at home. Okay? But that's what you're going to do. You're typically going to go through here, get rid of stuff that you're not going to need. Because life nowadays, we are data pummeled every second of the day with data. And the question is, so what? We get all this superfluous information that's not useful, but some of it is. You need to, as an intelligent person, you need to go through and figure out which is pertinent, which is not pertinent. Now on Dry Lab 2, there's no non-pertinent information, but your homework problem or your take-home problem will have non-pertinent. I'm showing you the assumption on your take-home. What I haven't given you is this. That'll be different. But the process you go through is the same. Do I need this information? If in doubt, leave it. If you know it's definitely not needed, cross it off. But if you're not sure, leave it. Because it's another conversion factor that may come in handy. Or you can align it any way you want. Yeah, whatever your system is, that's a good way to go.
Just, you don't wanna mix it up with the definites. You know, like a green, yellow, red sort of thing.
Yeah.
That'd be your yellow.
So you have highlighters.
I'm pretty sure everybody does. They give them out free all the time at like on Boost at school. I mean, you don't even need to go to the bookstore.
So that's a good way to use your highlighters. All right, so anyway, I just want to give you kind of a highlight of what your test is going to be like. And the strategy I'd like you to use, you can use any strategy you want, is just go through your data first. Try to simplify your data. Get rid of stuff you definitely know not there. Then you have stuff that maybe will be used and stuff that we're definitely going to use. 3 categories. Because you want to simplify, because it looks gargantuan problem, right? But it's not if you keep whittling it down as to what makes sense. Okay? All right. All right, so let's continue doing some more example problems. Are there any questions about the take home? It'll be available on Canvas files test related. Yeah,
Just a general question about Parkinson. General. I was curious, what's the relation of this chemistry?
do what?
Chemistry. Conversion, but like chemistry.
It's a
Like-
prep class for 1A, 2A, and 3A.
I know, but like, what's the connection to like chemical?
You need to know how much chemicals put into a test tube, you're gonna need testing hypotheses.
We have 4 units. Unit 1 is to get the math down. Unit 2, we're going to apply that math to chemistry.
So chemistry 1A is like not even chemistry 1A, it's more like math 1A?
No, chemistry 1A is chemistry 1A. There's a lot of
I've
math
never
that,
even taken a platform in my life, so this is not how I imagined it, so that's why I'm just asking.
He's talking about the different units, and one will be related to the math
Yeah.
part.
yeah, you need to know a math process. That's what unit 1 is.
Okay.
And then we're going to apply that process in unit 2 to chemistry. Things like using the periodic table of elements. Saying how many molecules of copper sulfate are there in 2 grams of copper sulfate? That's a chemistry problem, but you need to know unit 1 to do it. At all the conversion and the cancellation dialectic. That's how it relates. Is that
Yeah, I mean, it's my best academic subject math, but it's just with my disability, I get really mixed up in the middle of the process, and a lot of the times I go wrong from in the middle of the problem.
that's why this unit cancellation really helps.
Unit cancellation, like classes, what do you mean?
Just like we did here. See, we're
Oh,
canceling.
unit, you mean numbers?
No, units,
Yeah,
like miles or hours or seconds.
you'll probably see what I mean later in the class, like when it actually happens.
What's happening now?
No, when I actually mess up, you'll see what I mean.
Oh, all right. But if you do this process of unit cancellation, it really helps. Okay, just take my word for it. I've done this a whole bunch of times.
Yeah.
I've taught this class about 80 times.
Not this class, I had not the best experience, let's say, in my math class here, so.
Well, this is not your math class. This is
It is a
Chemistry.
ish class.
math, definitely math-ish. Yeah, that's one of the things that people don't like about chemistry is it's the beginning classes are all mathy. But once you pass the beginning classes, then you get into organic chemistry and biochemistry, and it's totally different. There's no math in organic chemistry. Zero.
Also, how big are you on showing work?
90% participation. I mean, 90% setup. I can't give you any credit for that. So just put on your thoughts. Think all you want in your head, but put it all down on paper so I can, because otherwise, if you miss the problem, I can't give you any partial credit. Okay?
Understood. Thanks, that answers my confusions.
Okay. All right. Are there any questions about this guy here? Okay. Now this is a typical test problem. In fact, I'm sure I haven't done the test yet, but I'm sure you'll have a speed question on the test. So again, fractions to fractions, 2 problems. The numerator, denominators are both separate conversions. That's the easiest way to do a fraction problem. Again, I want to give you experience on, over the years, my students have found that doing them separately like that is more obvious where the solution comes into play. Okay. All right, if a plane burns 34 liters of jet fuel per second that is fueled up in Canada. Now, this problem is real. This came out of the news where a 737 crashed in Canada because they put liters in rather than gallons. So the plane ran out of fuel because liters are about a quart and they're 4 quarts per gallon. So the liters are much smaller than a gallon. Okay, and it was not a nice landing either. When a jet runs out of fuel, it's a big glider. And metal gliders don't glide all that well. They do glide though. They really do glide. They don't just drop, they glide, but they go down fast. All right, so what's given here? Okay, so we're talking about 34 liters per second. Now again, per, that means it's a fraction. Okay, what are we trying to calculate is gallons per hour. So fraction problem again, it's 2 problems. We're doing liters to gallons, seconds to hours. Doesn't matter, again, which one we do first. The easiest one is which one? Do you need your conversion table to do the time version? No, hopefully not. Okay, so let's do the time one first. Okay, seconds have got to cancel, that means it goes on top. Notice I'm actually showing you the cancellation. Now, if you're a concrete person, do your own cancellation. You want to make it visual. Problems are always this way. If you go through here and read it. Now, this is more verbiage than you're used to seeing on my problems, but it's the same deal. So we have given, we're going to calculate, and then we're going to do conversion factors, do the conversion. Okay, so we've got seconds, now we need to do minutes. Okay, now we've got hours on the bottom. Okay, now we're going to work on the top. We need to get liters to gallons. Okay, we're starting with liters. So which one of these are you going to use? We've got a liters to gallon directly, right? So the liters have got to cancel. And how many liters do you, we've got one, 370, 3070. Huh? Yeah, 3 point. Okay, now, liters cancel. What are we left with? Gallons per hour. And again, I want to emphasize, everything needs to cancel except what you're trying to calculate. If everything cancels, your setup is wrong. Because you got to end up canceling everything except what you're trying to calculate. On the test, I want you to only use this conversion table. I'm going to give you a copy of it on the test. And only use this. Okay, so we're using 32,000 or so gallons per hour. A lot of fuel. SR-71 has to be refueled in midair after 15 minutes after it takes off. It uses that much fuel. Uses a lot. And it's the fastest plane, except for the X-15 around. And it was retired back in the 60s. You know what's something else interesting about it? Because its skin got so hot, the metal panels on it would expand as it got up to speed. They would get really hot. On the ground, it'd be condensed. So whenever they filled it up with fuel, it would leak until it got up to speed, then it didn't leak because the panels would expand. They used to fly those out of Beale Air Force Base. I used to go water skiing up at Bullard's Bar. You have to go to by Beale to go to Bullard's Bar, and U-2s would be taken off as well. But these SR-71s are wild planes. They would fly like at 85,000 feet. Officially means they're going to fly higher, unofficially. And the speed is Mach 3.1 or 3.2 times the speed of sound. Incredible plane. Looks cool too. And it's really big too. Big giant one. Okay. Sig figs. We're looking at 2 infinite. Okay, so we're gonna have 2 sig figs in our answer. So we're looking at 3.2 times 10 to the 4th gallons per hour. Okay?
Yeah.
Okay, how many square inches are in 49 square meters? So let's look on our conversion chart here for a second. Do we see any square anything? Do you see any cubic anything? So what we're going to do is we're going to convert our linear measurements to, don't shuffle your cards. Too noisy.
I get fidgety.
I know, but do something else.
I'm waiting until my embroider class.
Perfect.
Typically crochet, but I thought that would be the perfect thing. I could earn it plus fidgeting.
Yes, fidget with things that are silent.
In-
Okay, okay, so we need to figure out how to do this. Conversion from linear to square or from linear to cubic. Okay, so what we're gonna do is we're gonna invoke some laws. Oh, let's do feet. Okay, so 12 inches equals 1 foot. How much? That's linear, one dimensional. We're doing squared inches and square feet, that's two dimensional. So we have to impose squareness to all the units within here. That means we're gonna have 12 squared, inches squared, 1 squared, feet squared. Now we have a conversion factor that converts square inches to square feet. We want to do cubic inches to cubic feet, it can be the same kind of deal. So we're doing 12 cubed inches cubed equals 1 cubed feet cubed. So now we have square, cubic. So this is going to be 144 inches squared equals 1 square foot. Squared is 144. Okay. Now that same deal, does this make sense, by the way, what I just did? Okay. All right, so we're starting off with square meters. Now, do I have to square the 49? No, because it's already been squared. So we're not gonna, the conversion factor is gonna have the square number in it, but not what you start with. So the key is automatically we go up, we're working with square meters now. Yeah,
It's 49.3. Square.
details, details. Okay. All right. So how are we gonna do this? Okay, what are we starting with?
Square.
Square meters, okay? So that means we need to find everything with meters in it. And there's nothing with meters in it really. There's centimeters and kilometers and all this stuff, but nothing really with meters. So one thing we can do, we can convert to centimeters, square centimeters. And from square centimeters to square inches.
Could you also do meters, feet to inch?
Yeah. As long as everything cancels and you end up with fine.
Okay.
Seriously.
You get out for doing it.
No, not at all. No, no, there's not all the time, but frequently there's multiple ways to do the problem. And let's do it your way then. Okay.
But I'm only going off of the fact that it's.
Yeah.
The conversion factor, doesn't give.
Yeah. So let's get square centimeters. Okay, so how many square centimeters are in a meter? Well, how many centimeters are in a 1 meter? 100, so it's 100 squared then. Okay. And we're gonna have 1 squared, which is 1. And now we have square centimeters. Now, if we go from centimeters to inches. Okay, so how many inches are in a centimeter? 2.54. So that'll be 2.54 squared centimeter, squared 1 squared inches. So in this problem, the setup is really important because this may be tricky computationally to do on your calculator. But if you got the setup right, that's 90%. All right, so we're going to go 49.3 times 100 squared times 1 squared divided by 254 squared. All right. So we're going to go 49.3 Here we're looking at 3 sig figs, infinite, infinite. So this is going to be 3 sig figs answers. Okay, now all of you at your seats, try to do this on your own calculators. See if you get the same answer.
We're solving for inches.
Solving for square inches. Yes. Did everyone get 764 times 10 to the 4th?
That's what I got. Yeah.
Did you? Okay.
Question. I know when you were talking about the EE thing. Uh,
Yeah, let me see a couple.
it's so low. Unless I need it.
Should get to. So a little. Okay, and then. This is a carrot, so that's differentiation. And with that. So 5. Square.
Um,
And then also around here to change sign. And that's subtract.
Oh, okay.
Not the same.
Not the same, yeah, yeah, I knew that.
So a lot of people don't know what this is, they're saying, what this is. No. So this should be fun. We'll give you.
Okay.
Oh, it's like, she's got a 30 awesome. But hers is different tools. There.
Or target.
You're just fine. I was thinking. Okay, there. She's a big person. Your last lab, by the way, is going to be anti-inflation. And the indicator we're using is called phenolphthalein. And when you get to an endpoint, it turns burning pink. So she's not a good.
Peach, my favorite color too.
This sir collects bargains. And she's got a lot of pink related stuff in her house.
Oh, I collect designer dolls, so I have two dolls from Disney. On an Elsa pack, it's the two of them, and it's designer rated. So they were 300, but if you wait, they typically end up going on sale when there are the last few stocks. Cause they're only something out of thousands of them in the world, and then they get off half price, so I got it at $11.50.
Well, sister's got a lot.
Yeah, I only collect the designer ones.
She's got one that's $18,000. The first Barbie number one. It's
Jesus,
got holes in the thread, so in the standard got pennies. They have to put a hole in the food. Okay, she really, she presents internationally at Barbie conventions. And how to restore Barbie and all, she is Ms. Barbie. These are fashion shows from Kelly conventions. Most people collect dolls, and so she makes all her own clothes. She
did she make her own dolls?
reproduce dolls.
Cause I've seen people on Insta make like celebrity, make like a Katy Perry doll or make like a Taylor Swift doll. At least I heard just stuff.
She restores dolls. She does the makeup. She puts new hair in. Okay, so. Guys, what do you guys have with this?
And my
I
mom,
don't think she does it anymore.
Yeah, mainly I have a bunch of American Girl dolls. They're like.
Yeah.
They're nice stuff.
Yeah, she does other dolls. She has another.
I have the Elsa, blender. American Girl doll and I think it was the 2023 Christmas edition one, Sapphire Splendor.
Okay, I'm gonna be with you. Everyone get some answers, we.
I don't have anything where Martha's dead. And I don't have any. Yeah, it's a new perf. I got it for my birthday. I haven't exactly had the chance to organize it.
Okay.
It's just. And I really don't know.
Okay, so I'm gonna stop today and because lab 2 is longer than lab 1. I'm gonna give everyone plenty of time to do the lab. Okay.
We're having trouble figuring out what it went on.
Do what on Lauren?
We found it in the lab, stuff in the file, but we can't type on it.
Correct.
Where the.
So you load it in,
Come
have to load it into a PDF editor and then you can type on it.
Don't have.
There's
So
three
we're
P,
just going to do a Google Doc and I believe.
that's fine. It'll work.